Hi everyone. Today we are going to look at a problem here under forces and motion, and this is our video number 6 this time. So it means this is our 6th problem we're going to solve. Then after this one we'll solve one more problem and then we'll move on to something different. Not completely different, slightly different from this one. Because what we are doing here on these problems, here we are using Newton's second law of motion. We have used the first law of motion to solve problems upon that. This is the second law of motion, and once we finish this topic, we'll move on to Newton's third law of motion, and then we'll solve problems under that third law of motion. So let's see what the problem says here. The problem reads as follows: a resultant force of I plus 4J newtons, this is the unit of the force, acts upon a particle of mass 2 kilograms. Find the acceleration of the particle in the form Pi plus Qj meters per second squared. Now they want you to express the acceleration of the particle in this format. This is how they want it, in the vector form, but instead of in the vector form here. That's why they said Pi. This P and I, they're going to be numbers. Sorry, this P and Q, they're going to be numbers. So I and J, these are your vector forms. And part B says find the magnitude and bearing of the acceleration of the particle. So let's see. Here we have a resultant force of, let's say this is force F. Let's show it for F. This is equals to, is expressed like this: I plus 4J newtons acts upon a particle of mass 2 kilograms. So the particle, the mass of the particle M is 2 kilograms. And now you are asked to find the acceleration of the particle. ACC, I'll just put it ACC, comma, and this is A. So, we know these problems happens under constant acceleration. When we move on to the next topic, we shall be looking at problems later on, because after this we'll move to one topic, then the next one then will be wherein the acceleration is varies. It's not constant like this. So there are going to be different formula for that. For these ones, acceleration is constant. So use Newton's second law of motion, which says the force is equals to the mass times the acceleration applied by this force on the particle. So you have force equals to mass times A. Mass times acceleration here. Since the acceleration is constant with these problems, you use Newton's second law of motion. If the acceleration varies, this law is not applicable. There's a difference. There are different rules you're going to apply to solve that problem. So here we are given here. What are we asked to find here? We are asked to find A, acceleration. You are given the force, you are given the mass, you don't know this, they ask you to find this. So in that case, F all over M equals A, ACC. Let me just say that, acceleration. So what is our force? Our force here, A, which is the acceleration, is equals to, I'm taking it from here, the force, which is I plus 4J newtons times our mass, divided by our mass, which is 2 kilograms, which is 2. This is straightforward. There is nothing written here, so you know it's 1. There is a 1 here. They don't put it 1 times I is I. So there is a 1 here. So we are looking at numbers here. we are not going to consider these unit vectors we see, this I and J. We're going to ignore them because we are looking to find the acceleration of the particle. No, they ask us in the form, Pi plus Qj, correct? We are not going to ignore them. So it means this, we distribute, this division sign. So now you have I all over 2 plus 4 all over 2j. Because you are looking for acceleration, this is kilogram. Newtons per kilogram, this will change to meters per second squared. Yeah? The answer, the problem is solved already, but let's simplify. This is I divided by 2, you get 0.5 I plus 4 divided by 2, you get 2j meters per second squared. So this is the final answer. Okay? Fine. Problem number 2 says find the magnitude and bearing of the acceleration. Magnitude, bearing of the acceleration. Now this is the acceleration. You want to find the magnitude. So B, magnitude of acceleration. What do we get? You know how to find the magnitude of a force, a resultant force. We've solved so many problems concerning that. So what you have here, this one is going to give you the square root of the square of this one, 0.5 squared plus 2 squared. This gives you the magnitude of the acceleration. This one here gives you the magnitude. So let's simplify. Let's use the calculator. 0.5 square (0.25) plus, this is 4, so you get 0.25 plus 4, so this gives you 4.25. So what is the square root of 4.25? Square root of 4.25, 2.06, also 2.06 meters per second. No, sorry, no units. You are looking for magnitude. There is no unit. I don't want this to go beyond 10 minutes. Yeah? So that is the answer. So now you're asked to find the you're asked to find the bearing of the acceleration. Bearing, always, you draw your diagram. The acceleration, you know the I component 0.5, which is just like half. And the J component, this is I component on the x-axis here, and the J component on the y-axis, sorry. This is J component, and then it goes 2 units, that's same J component, here is 2 units. So this goes like this goes up 2, then we join it from here. This is what you get in a vector form. This is what you get, and the angle the vector makes with the I components, theta here, put it here. Correct? Put your theta there. So now they want you to find the bearing. We've got the magnitude, which is 2.60, and you're asked to find the bearing of the acceleration of the particle. So you have on the x-axis 1/2, and on the vertical axis you have 2. You want to find this angle. So what is theta? Well, we got to use the trigonometric identities. In that case, for this problem, you have the opposites and the adjacent to this angle theta. You have the adjacent and the opposite. So what trig function or trig identity should you use? You use the tangent. You know that tan of theta is equals to opposite, which is 2, all over adjacent, which is 1/2. Oh my God. 2 over 1/2, which is 4. So therefore, you want to find the angle. The tangent, the theta, is equals to the arctan of 4, which is equals to, again, we use our calculator. Arctan of 4. I'll get this. Tan of 4 equals 75.963. Let me just say 963.964 degrees. That is what you get. That is what this angle, this vector here, makes with the I component. But what are you asked to find? You are asked to find the magnitude, we got it here, and bearing of the acceleration of the particle. The bearing. You know, when we are doing bearings, we always take our initial position to be from the north pole. If you look at this one, this is north, east, south, west. North, east, southwest. So we are taking our initial position to be from here, from this north pole. So we now want to find the bearing of this vector. This is our vector, the acceleration vector to say. So we are looking at this angle from here to here. This is what we need. This angle from the north up to this vector here, not this one. This one will just help us to calculate this theta, to know what the value of this theta is. But actually it's this angle here we need. Let me call it gamma. Yeah, this is what we need. So that angle there plus this theta, sorry for messing up this part. You now have that angle, this angle here, from here to here, plus this theta angle. The two of them make up 90 degrees. You know that because this is a right angle triangle. From here to here is 90 degrees. Now you got this. You have this. This is what you need. So therefore, this angle here from the north to the vector is what you need. It's now 90 minus 75.964 degrees. That is what you need. So let's calculate that. You have 90 degrees minus 75.964. You got 14.036, which is, let's say, 14 degrees approximately. 14 degrees. Well, the degrees are written in this format: 0, 1, 4. They are written in 3 numbers. It's 14, but you read it as 0, 1, 4. This is how you write it. You can read it as 14 degrees, but when you write it 0, 1, 4, because it's 360, so you read it in that way. Thank you for watching. Bye bye.